In this presentation, I'm going to explain the introduction to electric drives, the basic concept of electric drive systems. Electric drives is a block diagram. Now, systems employed for motion controls are called drives. That is the definition of a drive. And prime movers shall be either diesel or petrol engines, or gas or steam turbines, steam engines, electric motors, etc., for supplying the mechanical energy for the motion control. These are all used for controlling the motion. Now, the drives employing electric motors are called electrical drives. The drives employing electric motors are called electrical drives. Now, let us see the basic block diagram of an electric drive system. There will be source is the, it can be either AC source or DC. AC can be either single phase AC or a three phase AC. And then there will be a motor will be there. Motor can be either AC motor or a DC motor or different types of like such a reluctance motor, brushless DC motor, like that. Different motors can be there. And there will be a power modulator. That power modulator controls the power flow from the source into the motor, and this represents the load. This is a mechanical load that is connected, and there are sensors are there sensing the speed of the motor or the rotor position, etc., and that is fed back to the controller, and controller will be giving the switching signal to control the power modulator in order to have a control power flow between the source and motor. Now the source can be either DC or an AC. In AC itself, it can be either single phase or a three phase. Now the power modulator converts the electrical energy of the source in the form suitable for the motors. For example, if the source is DC and the motor is induction motor, then the power modulator converts the DC into a variable voltage or frequency supply. Therefore, that is a function of the power modulator. Continuing diagram of electric drives, as I already explained, the power modulator, the role of power modulator. The power modulator also limits the current within the permissible values during the transient operation, like either starting, braking, or speed reversal, etc. During that, the current is being limited by the power modulator. And power modulator is usually a power electronics converter like control rectifier, that can be chopper or can be inverter or AC voltage controller or a cyclo converter or a matrix converter. That can be a power electronics based system, and that control unit produces the gate or base signals for the converter. That is, the controlling signal will be produced by the control unit that will be controlling the power modulator. And the parts of the electric drives, the main parts of the electric drives can be classified as we already seen. One is the electrical motor, that is the electrical motor is the one of the part. Then power modulator, as we already seen, the power modulator. Third is source. There are different types of source, either DC source or AC source, even single phase or three phase. And the load, this is the mechanical load, what type of the load we are connecting. And the control unit, this is the control unit that is getting the signals from the sensor, that is controlling, producing the switching signals to the power modulator. Continuing the block diagram of electric drive system, in which I told you the electrical motors, that's the one part of that one. This is the electrical motor. Now electrical motors can be DC motor, that can itself be separately excited DC motor, or a shunt motor, or a series motor, or a compound motor. There are different types of motors that can have. Then AC motors, if you see that induction motor is there. Induction motor either can be squirrel cage induction motor or a slip ring induction motor or a linear induction motor. There are different types of induction motor can be had. And the synchronous motors can also be had. One field synchronous motor or cylindrical rotor type or salient pole type, and permanent magnet synchronous motor. Therefore, there are different types of motors can be this part of a electrical drive system. And the brushless DC motor, stepper motor, switch reluctance motor. So these are the different types of motor that can be used for the electric drive applications. That in that one, motor is either AC motors or DC motor or it can be either single phase motor. A single phase AC motor is a three-phase AC motor is a synchronous motor is a, there are different types of motors that are available. Continuing the electric drive block diagrams. In the past, induction and synchronous motors were employed mainly for the constant speed applications, and variable speed applications were dominated by various DC series motors. Now, AC motors are also used for variable speed application because of the development of power electronic circuits and devices. And wound field permanent magnet synchronous motors have higher full load efficiency and power factor compared to the induction motor, but cost, size, and maintenance is more in the case of synchronous motors. Then brushless DC motor is the almost similar to permanent magnet synchronous motor, but its characteristics are that of the conventional brush, the DC motor. The characteristics is similar to the DC motor, but its working is it is almost similar to the permanent magnet synchronous motor, but has lower cost and requires simpler and cheaper converters. It is extensively used for high performance drives, computer disk drives, servo drives, robotics, electric vehicles, etc. This type of brushless DC motors are widely used. In the previous slides, we have seen the motor, different types of motors, DC motor or AC motor, that is a single phase or three phase, and different motors, permanent magnet synchronous motors, etc. Now let us see what is the power modulator. What is the role of the power modulator? The power modulator modulates or controls the power flow from the source into the motor. From the source into the motor, the power flow is controlled by power modulator in such a manner that motor is producing the speed torque characteristics as demanded by the load. The load will be demanding certain speed torque characteristics. We are controlling the motor in such a way that the motor is producing a speed torque characteristics that is demanded by the load. That is the purpose of the power modulator, to produce the required speed torque characteristic. Second is that during the transient operation, like during the starting of the motor, during the braking of the motor, during the speed reversal of motor, during the transient operation, the speed reversal of the motor, the current drawn from the source are controlled within the limit, that is within the permissible limit. Current is brought by this power modulator. That is the second purpose of the power modulator. Third purpose is that the power modulator converts the electrical energy of the source into the form suitable to the motor. That is why here, if the input is a DC source and if the motor is an AC source, then the power modulator is a DC to AC converter, that is called the inverter. Now instead of that, the input is an AC and the motor is a DC. It is an AC to DC converter. It is a control rectifier. Now if you have an input is a DC, fixed DC, but you want to get a variable, it's a DC motor, it's a variable DC voltage, then you will be getting the chopper. Therefore, depending upon the motor and the source available, the role of the power modulator will be changing. That is, the power modulator converts the electrical energy of the source into the form suitable to the motors. Continuing the power modulator, the power from the source side, it is taken and that is converted into a required form, either AC or DC. That depends upon the type of the motor used. Therefore, it can be AC to DC. If the source is AC and if the motor is DC, AC to DC converter is there. That is what we call as a rectifier. Control rectifiers will be using. Now, if the source is DC and of course source is DC and also the motor is also DC, then a DC to DC converter, that's a chopper, is using here. It is a chopper that will be using this one. Now, if the source is a DC, but if the motor is an AC motor, that is DC to AC converter, you want to write a variable voltage, variable frequency, in that one we will be using an inverter. Now, if the source is AC as well as the motor is also an AC to AC converter, AC controllers are there, then cyclo converters are there, then matrix converters are there. Therefore, these are the different types of power modulator depending upon the type of the source and the type of the motor used. Therefore, it can be AC to DC converters, that is source is an AC and the motor is a DC. It can be single quadrant type, that is motoring operation, is possible with a half control bridge rectifier. You can have a single quadrant operation is possible. Now, if you are using a fully controlled rectifiers, it can have a two quadrant operation like forward motoring and regenerative braking is possible. And if you are using a four quadrant operation, that is, if you are a four quadrant operation, it can be used by a dual converter. If you are using a dual converter, you can have a four quadrant operation of the motor. Therefore, the type of this one, whether it is a single quadrant operation or a single half control rectifier, a fully controlled rectifier, a dual converter rectifier, the motor can be operated either a single quadrant, two quadrant, or a four quadrant operation. Therefore, this is the motor, and this is the source, and this is the power modulator. There will be a sensing, sensor is there to sense the speed and rotor position, etc. That is given to a controller. That controller controls the power modulator, and this is the mechanical load that is connected. Based on the mechanical load, speed, torque characteristics, we are selecting the motor, and we are controlling the power modulator in order to have a speed, torque characteristics that is demanded by the load. Second type of power modulator is a DC to DC converter, that's called a chopper. That is, the source is a DC and the load, motor is an AC motor is, DC motor is there and DC source is there. Say fixed DC is available, but you want to get a variable DC because motor is a DC, or DC to DC converter, that's also called chopper. Because the source is a DC and the motor is also DC. That can be either single quadrant type or a two quadrant type or a four quadrant chopper. For the chopper can be either a single quadrant type or a two quadrant type or a four quadrant type of chopper. Now the third one is called, third part, the type of power modulator is AC to AC converter. That is, input is an AC and output is also AC. Therefore, AC to AC converter, that can be used by either it is AC controllers or a cyclo converter or matrix converters. AC voltage controllers can be used for the control of induction motors with a stator voltage control at a constant frequency. Cyclo converter or a matrix converter, single stage AC to variable frequency AC conversion, can be used for variable voltage, variable frequency output for the speed control of induction motor using stator frequency controller. That is, AC to AC converters can be used. For variable frequency voltage, two-stage conversion is used. First stage is AC is first converted into a fixed DC using a diode bridge rectifier, and this fixed DC is converted into a variable magnitude voltage and frequency AC voltage by using inverter. Therefore, an inverter can be used to get a variable voltage, variable frequency output. Therefore, DC to AC converters, inverters have source is a DC and the motor is AC. Therefore, in this is source is DC and the motor is AC. Therefore, fixed DC voltage is converted into a variable magnitude, variable frequency AC voltage. That is done by inverter. Either you can use a sine PWM technique or a space vector modulation technique like that one. It can be voltage source inverter or it can be a current source inverter, VSI or CSI. There are two types of inverters available. For output voltage control and for the reduction of the harmonic, sinusoidal pulse width modulation, SPWM, sine PWM, or space vector modulation or SVPWM techniques can be used. Therefore, different control technique can be used for controlling this inverter. That is to control the output voltage and frequency given to the stator of the induction motor. It is a DC to AC converter. It is also a power modulator. Now, coming to the different types of source, as I already told, it can be either DC source or it can be AC source. Therefore, sources can be either AC or DC. Now, AC type, it can be either single phase or a three-phase. Ticket AC supplies are readily available. Lower power drives are fed from a single phase source, and the rest of the drives can be fed from a three-phase source. Most of the motors are fed from 400 volt three-phase supply, and large motors are operated by from 3.3 kV or 6.6 kV, 11 kV, etc. Therefore, source can be either AC source or a DC source, and either AC source itself, it can be either single phase or a three phase.
that is the source. Now what the remaining is the control unit. Control unit is for the power modulator, that is control unit provides the control signals, controls the power modulator. For control unit controls for the power modulator, and they are provided by the control unit. The control signals are provided by the control unit, and the speed as well as the rotor position or the current, etc., that are sensed by the sensors, and this can be sensed, either speed, position, current, etc., can be sensed by the sensors, and they are given as an input to the control unit. The input to the control unit is the parameters, either motor current or can be speed or the rotor position, etc., that are the inputs given to the control unit, and we'll be providing the reference value, what the required speed, required current, etc., that is given as a reference value, and based on that one you are producing the control signal which controls the power flow between the source and motor. This is an overview of the different types of converters used in electric drive system. As you know that it is a AC to DC. All these are explaining input is an AC and output is either a fixed DC or a variable DC. Now if the first one, if you see that one, input is either a single phase or a three phase, and if you are using a diode rectifier, you can get a fixed DC voltage. The voltage available here is a fixed one. Now if you are using a half control SCR, half control rectifier here, then you'll be getting a variable output voltage. Okay, fixed AC voltage is there, and you'll be getting a variable DC voltage available. Half wave control rectifier. It's an AC to DC converter. Similarly, if it is a fully controlled rectifier, again it is a either single phase or three phase. Input voltage is the output is a variable DC voltage. Now this can be used for a two quadrant, because you can have either positive voltage or negative voltage, but in this case you can get only the positive voltage. This can be used for a single quadrant operation. Therefore both these are half controlled rectifier, and this is a fully controlled rectifier. It's an AC to fixed AC to variable DC. Now here if you see another, if you are giving a fixed AC, that is using a diode rectifier that is controlled to a fixed DC, and using a chopper, by controlling the duty ratio of the chopper, you are getting a variable DC output. Therefore input is a fixed AC, either single phase or three phase, and the output of this one is a variable DC that can be made variable by controlling the chopper duty ratio. Now this is a one method of mechanical method rather than power electronics devices. If you have an AC is there, previously this was a method we'll be using, and here AC is given to a three phase AC is given to an AC motors, and that AC motor is coupled to a DC generator, and the field is given to here, and by controlling the this field current, etc., the output voltage available, the DC voltage available is, this is a DC generator, the voltage can be controlled. Therefore this is by controlling the field current, you can control the induced voltage or the voltage available at the output of the DC generator. Therefore input is an AC, but output is a variable DC. This is a mechanical method of generating from AC to DC voltage. And now other here, if you see that one, another one, if you are giving an AC voltage here and input is, and if you are using an AC alternator, again this alternator you can changing the field current, you can vary the voltage available at the output of the alternator, and that voltage is given to a diode rectifier, and we are getting a DC output voltage. Again here, by controlling the field current, you can vary the voltage available at the output of this one, and even the speed of this one also can be controlled, and you'll be getting a variable output voltage at this one. This is another mechanical method of generating variable output voltage. For all these we'll be explaining from an AC voltage, either single phase or a three phase AC voltage, how can you get a fixed DC or variable DC output voltage for AC to DC converter. This is a one type of different types of converters used for the electric drive systems. Continuing the other type of converters used in electric drive system, as you know that one, here an AC input is there, and here AC output is there. It is a AC to AC converter. Therefore you can use either single phase or AC phase. If you are using an auto transformer, you are getting a lower value of the output voltage. Variable voltage can be changed by the step turns ratio of the secondary. That is a auto transformer. Either transformer with different turns you can have. Here you can get a variable voltage available, and from a fixed AC you can get a variable AC output voltage. Another method is that if you are using a diode rectifier, that is if you are using, in this case we are using a thyristor voltage controller. By using a thyristor voltage controller, it is a AC to AC converter. This is by controlling using the thyristor controllers, you can AC controllers, you can change it. You are getting it from a fixed AC, you are getting a variable AC output voltage. And now another is a magnetic amplifier. That's not much using nowadays, but for it is very rugged constructions, military purpose still it is being used. And this is the magnetic amplifiers. Another, these are all AC to AC converters. Now coming to this one here, DC to DC converter. You have a fixed DC, you are getting a variable DC. That is, as you told, this is a chopper is we are using. By controlling the chopper, either a single phase chopper or a two phase chopper, I mean a single, not single phase, single quadrant chopper, it is a two quadrant chopper or a four quadrant chopper, like that. By using the different quadrant choppers, we can have different types of control of this motor that is connected at this end. Anyway, basically, chopper is a DC to DC converter. You can get a variable DC output voltage from a fixed DC output voltage by controlling the duty ratio. Now, these are the DC to AC converter. That's called the inverters. Now, if you are using a square wave inverter like stepped waveform inverter here, in this case, here giving a fixed AC input, but the output frequency you can change, but output voltage magnitude cannot change in this method of that one. Now, instead of this one, if you are using a sine PWM technique or a space vector modulation techniques, even with a fixed DC input voltage, you can get a variable voltage, variable frequency output by controlling the modulation index, amplitude modulation index, and frequency modulation index. You can get a variable voltage, variable frequency output from a fixed DC voltage. These are the inverters. There are different types of inverter which converts DC into AC. Now, one more pending is that if you have a cycloconverter, cycloconverters can be converted from AC to AC converter from one frequency into another frequency. Therefore, these are all the power, modulator, different types of power modulators available for controlling the power flow between the source and motor. Let us see the advantages of electric drives. What are advantages? Flexible control characteristics, that is, steady state and dynamic characteristics of the electrical drives can be shaped to satisfy the load requirement. Okay? What the load demands, that type of characteristics can be produced by the controlling the electric drive system. Speed can be controlled in a wider range, and electrical braking can also be employed efficiently by using power electronics switches. That's the first advantage. Second, they are available in wide range of torques, speed, power. In electric motors are available in wide range of speed, torque, power, etc. Then electric motors have high efficiency, low no-load losses, and short time overloading capacity. That is, it has got better short time overloading capacity is more here, and it can have higher efficiency, and no load losses are very less. Now, electric motors do not pollute the environment. That's another advantage compared to the other type of IC engines or petrol engines, etc. The pollution is zero. That is, electrical motors do not pollute the environment. Then it can operate in all four quadrants of speed torque plane. That is, it can be operated in forward motoring, first quadrant; second, forward regeneration; third, reverse motoring; fourth, it is reverse regeneration, etc. All four quadrant operation can be possible in the case of electric motors. Then electric braking provides smooth deceleration and increases the life of the equipments. When regenerative braking is possible, considerable saving of energy is achieved, because it can feed back the energy from the motor. In that case, motor is working as a generator, and it can be fed back into the source. That's called regenerative braking is possible in the case of electric motors or electric drive systems. Unlike either prime movers, there is no other prime movers. Unlike other prime movers, there is no need to refuel or warm up the motor. That is not required in the case of electric motors. It can be start. It can start immediately and can immediately be fully loaded. That is possible in the case of electric motors. So these are the advantages of electric drive systems.